Hey everybody, so this is a unique question asked in your Cambridge exams as far as chemical energetics is concerned and Hess cycle is concerned. But please always remember, and this will be my advice to you as a student, always think to yourself whenever there's a new type of question, think to yourself, what can I use the data given to me for, right? How can I solve and how can I efficiently use the data which has been given to me? Try to solve it even though you might not reach your answer, but as you keep on solving it, you'll develop this problem solving attitude. Okay, this data is given to me, I can calculate this from this data. Okay, once I've gotten this is not my final answer, but I need that. So you slowly and gradually, your brain will start to connect the dots slowly and gradually. So never get scared if there's a new type of question. Always make the best use of whatever data is given to me. For example, he's given me formation data in this question, and I can make use of formation data, right? He's given me the formation data of PCl3 and POCl3, and I know how to use formation data. I'll make my 3-box diagram, write the entire equation in this 3-box diagram, which is PCl3 plus O2 gives me what? POCl3. POCl3, right? And what's the balancing for it? He's given me that, hey, 2 PCl3 gives me 2 POCl3, right? So 2 PCl3 gives me, I'm gonna put a 2 here and a 2 here. And he's given me formation data. He's also given me something, the oxygen's data right here, the bond enthalpy for oxygen, right? Because you know, bond enthalpy is when 1 mole of covalent bonds break for 1 mole of gaseous molecules, right? And this is what's happening. 1 mole of covalent bonds, specific covalent bonds are breaking, and he's given me this data. What has he given this data to me for? I couldn't care less for now, right? I don't know for now. As a student, I wouldn't know, but I know how to use my enthalpy change of formation data. I know that enthalpy change of formation of PCl3 is minus 289. So I'm going to plug this right here, minus 289 kilojoule per mole. But remember, formation data is for 1 mole of a substance forming from its constituent elements in their standard states under standard conditions, right? So this is 2 moles right here. So I'm going to multiply this by 2. We all know that. Oxygen's formation is always 0. It's a null reaction. It's element going into element. Nothing is really changing. No chemical change is taking place. So it's a null reaction. POCl3 is right here. The enthalpy change of formation is minus 592 right here. Right? And because enthalpy change of formation is for 1 mole, here you have 2 moles. So I'll multiply this fella with 2 times it by 2. And this is what I don't know. So what I can do is I can use my Hess cycle to actually calculate X right here. See, I'm not even concerned about the requirement of the question, because once as a student, if I could give a look at it, I'd be confused. I'd be like, hey, PO bond, how can I calculate this? Oh my God. Stop thinking on what has been asked. Also, just give it a read. But if you can't make sense of it, make best use of the data given to you. So I'm going to make best use of the data given to me, and I'll actually figure out X, right? So the indirect root equals the direct root. I can actually figure out X, right? So X equals, and that wouldn't be my answer obviously, but minus 289 times 2 plus X equals, and plus 0 you could write, but plus 0 is whatever, nobody cares. The direct root equals the indirect root as per Hess law and or Hess cycle. Can you guys calculate X for me? It is minus 298 times 2. On the right hand side it will be positive, and then minus it right here. So it would be X minus 592 times it by 2 plus 578 right here. This value is 578, right? Now X equals, can you guys calculate this stuff? Minus 592 times 2, that gives me this, plus 578. I get minus 606 kilojoule per mole, right? Minus 606 kilojoule per mole. Now this minus 606 kilojoule per mole is the enthalpy change of this particular reaction, right? I don't know what this particular reaction enthalpy change, what this particular reaction's enthalpy change was, but now I've calculated it through Hess cycle, right? Although this is not the requirement of the question, but I've calculated it. It's minus 606 right here. Now I know that enthalpy change for any particular reaction, how do you calculate it? Enthalpy change of a particular reaction, it's bonds broken minus bonds formed, right? And let's now start to break the bonds and start to form the bonds, because once I now look at the requirement of the question, it says find the bond energy of PO in POCl3. I have to find this fella right here. So bond energy ke liye I have to break bonds and form bonds to figure out bond energy, right? And before all of this, I first of all figured out the enthalpy change. So let's break the bonds, right? You have PCl3, it would look something like this. I couldn't care less, I'm not drawing the shape for it. I'm just drawing it, the structural diagram for it. This is PCl3 and you have 2 moles of this. So how many PCl bonds do you have? How many PCl bonds do you have to break? So PCl, Cl, Cl. So you have 1, 2, 3. You have 3 PCl bonds here and you have 2 moles of that. So in total you have 6 PCl bonds. So 6 bond energy is required to break the PCl bond, right? And then don't worry if you don't have the value for it. Don't worry. Just keep on doing it. Oxygen, O2. This is how I break the O2 bond, right? So O bonded to O, 1 O bonded to O. This is the bond that I have to break. And what's the energy given out during bond formation? So that is POCl3 is forming, right? So POCl3 would look something like this. P double bonded to O, Cl, Cl, Cl. I couldn't care less, right? I couldn't care less about the actual shape. I'm just curious about this particular structure form for it, right? So this is POCl3 and 2 moles of this is forming. Now, the question is, how many PCl bonds are forming? So 1 PCl bond, 2 PCl bond, 3 PCl bonds. And since you have 2 moles of that, how many PCl bonds are forming? So you have 2 moles, you have 2 times 3, that's 6 moles of PCl bonds forming, right? 6 PCl bonds are forming, right? Great stuff. And how many PO bonds are forming? So right here, it's P double bonded to O. That's for, in 1 POCl3, you have 1 P double bonded to O, and you have 2 moles of this. So 2 times P double bonded to O is forming. So plus 2 times P double bonded to O, this bond is forming. Now, look at the idea. Can you guys calculate the enthalpy change of the reaction? Absolutely, I can. It's what? It's energy taken in during bond breaking, PCl plus 1 times the oxygen bond is going to break, minus this entire is the energy given out during bond formation. So minus energy given out during bond formation is what? 6 PCl bonds plus 2 P double bonded to O. Done. Now look at the idea. You already have the enthalpy change of the reaction. You figured this stuff out. It is what? Minus 606. Minus 606. 6 PCl bonds. I don't know the value of PCl bonds. I'll just write 6 PCl bonds plus 1 OO bond. What's the energy taken in to break 1 OO bond? That's 496. I'm going to write 1 times 496 minus 6 PCl. I'm going to multiply minus with this and then minus with this, right? So 6 PCl bonds, and you'll see something beautiful. Although I did not know PCl, what PCl was, and minus 2 PO bonds, right? Now, although I did not know 6 PCl, the value of PCl bond, I did not know this value, but this is minus 6 PCl and this is plus 6 PCl. They literally cut out, cancel out. And so what you're left with is 606 equals 1 times 496 minus 2, and I'll just call the PO bond X, right? So I'll just call this X, right? And then you shift the values, calculate for X. This goes there, so it's minus 606 minus 496 equals minus 2x, right? And so what do you get? Minus 606 minus 496, that's minus 1102 equals minus 2x. Minus minus cuts out. What is x equal to? And x is actually the bond enthalpy of PO bond. This divided by 2, what do you get? 551 kilojoule per mole of the PO bond. This is the actual answer, 551. So although you might think that it's a little far-fetched for a 2-mark question, but it is what it is, guys. It's a piece of cake. Just don't forget to keep on solving. Keep on solving. You'll reach there, I promise. Just keep on solving and try to use your brain from time to time. Take it. So this was the idea behind it. And if you are good in math, you don't have to do all of it. You wouldn't have to do all of this stuff. You just realize what's going on, right? So I had to just quickly explain it, and that's it.